The first question, the relationships activity, involves describing two problems with this data set. Now have a quick look at it, because you will see that first of all there's data redundancy. There's lots of data that's repeated. You've got the item name repeated multiple times. And as part of that, you'll see there's actually an update anomaly, because on the second and third row down, you'll see that face mask is spelt wrong. Now, if that needs to be changed or updated, then we need to change that for every instance. And this is just a snippet. There could be hundreds of those misspellings in there that we need to fix. The delete anomaly is something that if you delete one item, you have to delete them all. So if we're going to delete AA916, then we have to delete every copy of that from the database. And that's easier said than done. We can probably control F it, but if we've got any update anomalies in there, we're not going to find all of them, and that's going to lead to some issues for us. And that's mainly the problems which we're going to get from non-normalized data. Now, in restructuring this table into third normal form, we'd start with an items table. So we've got an item code, the name and the manufacturer code, and notice then we only have one of each item, so that makes it much more efficient. We split the manufacturer code off into its own table, so we've got the manufacturers, there are only two, so they're split off separately. The shops then, there are only 3 shops in that list despite the amount of records there, so we can split that off on their own. And then we need a way to link those all together. So we have a stock table, because we've still got that number in stock that's missing. So we've got an item code, which is the actual physical item, and a shop code. Now that contains all the information we need and is linked nicely. The second activity, which is a bunch of SQL commands on those tables. The first, write an SQL command to output the names and prices of all the items, is going to be a simple one, which is select item name and price from items. That will give us all the results with just those 2 fields, as we've asked. Question 2 just adds a criteria to it. It adds where manufacturer ID equals 7, and that limits it to only showing the records where that manufacturer ID is the number 7. Part 3, changing the shelf life to 90, where it's currently set to 120. We need an update command for that. We need to update the items table. We need to set the shelf life to 90, where shelf life is currently equal to 120. That will change all of those to 120. Write an SQL command to output the names of all items where the manufacturer is the same as item 124. So this is reasonably straightforward. It's a simple select query, so select item names from items where manufacturer ID equals, and then we just do brackets and do a subquery. And that's another query that just goes and finds the manufacturer ID of that item ID. The next one, creating a table. We're going to create the table called stores, and the fields in it is store ID, which is an integer and a key field. The location is text, and it's a maximum of 30, and that's just a realistic number. And the next one's a size, and that's an integer. We don't need to give a number to that one because integers have standard sizes. You could, of course, have done this slightly differently. You could have done store ID int comma, and then the last argument could have been key field brackets store ID to illustrate it that way. And then inserting records into it, insert into stores values, and then those values need to be in the same order that you created the fields in. Key field, name of store, square meters. Same for the next store, same sort of style. Data dictionary from that one, what we're going to do is we're going to take the headings that we know, field name, key field, type, length, and validation, and go through each of those fields, the headings in that red table. So the first one, let's do student ID. That's a key field, it's an integer. Validation, we need a presence check on there that needs to be there, and it needs to also be unique. How about the first name then? Well, it's not a key field, it's going to be text or string. Arbitrary value for that, 128, because I'm a nerd, but something 50-ish would be good for that. Validation, presence check, must exist. How about surname? Same. How about email? Well, it's a string. I got a bit more space for that one because email addresses can be quite long, and I've said a format check would be good there because there must be an at and a dot. In fact, given our data sets there, at test.org might be a good shout for what the email address should contain. Date of birth then, the type of that is a date type, which we don't get in a lot of programming languages, but it exists here within the database. A length of 10, that's the amount of characters it will be. It's the numbers plus the slashes. And we use a range check on that. We say it's going to be one in the past because, or maybe less than or equal to today, in fact, because you could be literally born today, couldn't you? And the last one there is gender. It's a string. It's a maximum of 6 because we've got 3 options there, and the biggest one has 6 characters. And it's going to be a lookup check that just has a list of male, female, or other, and it must be one of those. So the big data activity, We need to explain big data first of all. So big data refers to data sets so large and complex that it becomes difficult to process using standard relational database techniques. That's an exam answer that comes straight out of the mark scheme. What's data warehousing then? It's storing big data so that it can be accessed and processed. Fair enough. Give an example and explain why data distribution may be used when performing these activities. Well, data distribution is where data is stored over multiple sites, servers, and computers. So the example of this could be storing all the Amazon sales data, for instance. It's resilient storage. If we lose one data center, we can still access other stuff. We reduce the cost. The volume of storage as a single piece would be very expensive, but buying lots of smaller parts, even if it is huge, is going to be significantly cheaper. And finally, security. The only data that needs to be accessed by certain users can be accessed, and we can even limit that on a server level.